Good morning, everyone. My name is AhmadKamaludin, a grade 12 student specializing in computer and network engineering. Today, I will present my capstone project, the Unified Network Management Overview. I didn't just build a dashboard, I built a bridge. As someone who completed an internship at an ISP, I realized that many network issues arise from a lack of clear visualization. We often look at terminal lines and miss the bigger picture. This React-based dashboard is designed to solve that problem by providing human-centric approach to network administration. As discussed in my analytical text exposition, visual monitoring reduces human error by up to 40%. This project is the practical application of that theory. Let's start the dashboard. Let's look at our first KPI, network latency at 15 ms for an admin. This is our pulse. If this spikes to 100%, I don't need to wait for user complaints. I already know the backbone is congested. We see 99% system uptime. This is achieved through a redundant system configuration. This dashboard tracks how many seconds we've been online since the last reboot of the core router. The center graph shows the real-time network traffic. I choose an area chart because it clearly shows the volume of data. The fluctuation. This is help us to identify if our bandwidth limit is being consumed by meaningful traffic or potential DDoS attacks. An admin can toggle between 7 days, 30 days, and last 3 months. As you can see in my sidebar, I have some menu here like network topology, active devices, traffic analytics, security and firewall, system log, and I also have AI power tool here like AI Insight, anomaly detection, and network bot. Next to network topology page. Most people don't understand network hierarchy, but with this topology page, anyone can. We see the flow internet to Mikrotik, then to Cisco, down to the access point. If a technician says the Wi-Fi in lab TKJ client TKJ is down, I just look here. If the icon is green, the issue is likely a client-side password error. If this red, I know the physical link is broken. This is the most functional page. Look at the MAC address column. In school environment, security is about identity. Here, we track exactly which device belongs to which user. We can see MikroTik CCR core consuming 145 Mbps through Ether 1. I've also implemented a block status for unidentified mobiles which prevents unauthorized access to the local server. Next is traffic analytics page. On the analytical page, I broke down the bandwidth distribution. It's not enough to know how much data is used. We need to know who uses it. The pie chart shows the percentage of user per department. This allows us to implement fair usage policies, so the office staff doesn't get slowed down by students downloading heavy files. I almost forgot to tell you about the data integrity. While the interface and the monitoring system you see here are fully functional and ready to be deployed, the data currently being displayed is simulated data. In, in production environment like ISP I work at during my internship, this dashboard would be connected to a live API from a magnetic router or an OLT device. However, for this portfolio demonstration, I'm using mock data engine that I built within the React application. This is standard procedure in software development called sandboxing, which allows me to demonstrate how the system reacts to specific scenarios, such as high latency spikes or unauthorized access, without needing to cross a real school network. But rest assured, the logic behind the charts, the firewall triggers, and topology status is 100% correct and based on real network engineering protocols. Now, let's talk about security. This page lists recent security threats. We detected a port scan from an external IP. My system automatically blacklists that IP and added it to the blacklist table below. This is what I call automated infrastructure defense. The system logs like us the digital black box of our network. Every login attempt, interface link, up and down, and backup completion is logged here. For NOC Network Operation Center Specialist, this is the most valuable page for post-incident analysis. I've pushed this project further by adding AI-powered tools using Gemini Flash models. The system performs anomaly detection. It scans 45,000 packets per second to find DNS tunneling or traffic spike. The AI Inside page even gives recommendations like increase queue limit to 500 Mbps because it predicts a 30% traffic increase tomorrow based on historical data. This is predictive maintenance. Building this dashboard required a deep understanding of both networking and software development, and it proves that as a grade 12 student, I am ready for professional NOC role. As required, I have also completed my analytical exposition report, this handwritten on paper, detailing the argument that data you've seen in this demo today, all identity, document, and technical prints are ready for submission. Thank you for your attention.